trusted results on the IMViC test, right? So folks, remember we're comparing E. coli to its close cousin Enterobacter aerogenes, and E. coli is, as we have talked about before in lab, is an indicator of fecal contamination. So, folks, why are we so concerned about fecal contamination of food or water? Pathogens, like what? If I asked you on the lab exam to name a viral pathogen that could be present in fecal contaminated food or water, could you give me some examples of viral pathogens that might be present? So virus, polio, good, excellent, you guys, polio, right, what we've just been talking about, good. In addition to polio, guys, and we haven't talked about these other viruses, so don't worry about them, but the norovirus, which can cause diarrhea, which seems like it's spreading. Another one would be the hepatitis A virus, is fecal oral transmission. Okay, just a few. Good. Guys, if I asked you for a bacterial pathogen that could be present in fecal contaminated water, could you give me maybe one or two examples of bacteria that could be present? Okay, so Shigella is good, you guys. Shigella dysentery causes bacillary dysentery. Good. Clostridium difficile, the endospores. Good job, you guys. What about the E. coli 0157H7? Remember the one that causes hemolytic uremic syndrome? Good. Vibrio cholera causes cholera. Salmonella. Yeah, now, oh my gosh, you guys. Thanksgiving coming up. Let's think about all the fecal pathogens that come along with Thanksgiving dinner. So Campylobacter, right? Salmonella. Okay, all bacteria that could be present in fecal contaminated food or water. Good job, you guys. And now let's move up to the protozoa. Can you remember two protozoa, folks, that we studied, that the transmission is fecal orally, we ingest the cysts? Giardia, good job, folks. And maybe if we're traveling in the tropics, Entamoeba histolytica, good. And folks, and this is actually a good review, you guys, for the helminths. Can you think of two helminths that we studied whose eggs might be present in fecal contaminated food or water? Ascaris, right, the human roundworm, good. And what it would be really, this one would be really bad to get, you guys, because it could end up in us suffering from neurocysticercosis. Do you remember that one? Taniosolium, good. So you guys, this just gives us an idea of why we're so worried about fecal contamination or food or water, right? If feces is present, any of those fecal pathogens could be present. And you guys might recall, I think we had discussed this earlier, that it would be so expensive and take so much time to screen food and water for all those different pathogens. So remember what they decided? They decided we'll choose a microbe that's always going to be present in feces, a microbe that's easy to grow, doesn't take a lot of time, easy to identify. So do you remember which organism they chose to be the indicator organism? E. coli, good, you guys. Okay. Now, the reason the IMViC test can be really important is E. coli has a close cousin, Enterobacter aerogenes. They both belong to the same big family, Enterobacteriaceae. They're both gram-negative bacilli. They both ferment lactose with gas production. But, you guys, the natural history is different. Enterobacter aerogenes, it can live in the intestines, but it can also live just out in decaying organic matter, right? So if we had food or water that only had Enterobacter aerogenes in it, it might not indicate fecal contamination. It might be just like runoff, maybe, from the forest floor, something like that. So the public health microbiologists developed the IMViC tests so that within 24 hours we could distinguish whether the Enterobacteriaceae that we were isolating from food or water, if it was E. coli or Enterobacter aerogenes. And the reason these tests are so awesome, you guys, guess what the results are? They're opposite. E. coli has the opposite test results as Enterobacter aerogenes. So let's see if our test confirm that E. coli and Enterobacter should have opposite results. So you guys help me out here. When you ran the indole dry slide on E. coli, what color was it? Red, good. Is that positive or negative? It's positive. And so you guys, that means your E. coli makes which enzyme? Tryptophanase, awesome, you guys. Now, what happened when you ran Enterobacter aerogenes? What color was it? Not red, right? So is that positive or negative? Yeah, that's negative. And what does that tell you about your Enterobacter orogenes? It doesn't make tryptophanase. Good job, folks. Okay, and then on your methyl red, when you added your methyl red pH indicator, what color was your E. coli methyl red rock? Good. Is that positive or negative? Good. And what does that tell you about E. coli? It uses mixed acid fermentation. Great, you guys. And what about your Enterobacter orogenes? When you added methyl red pH indicator, what color was your methyl red rock? Was it not red? Yeah, not red. Okay. And is that positive or negative? Negative. Good. And what does that tell you about Enterobacter orogenes? It doesn't carry out mixed acid fermentation. Good. Now you guys remember the VP test we did as a demo, and it often takes 30 minutes for the color to develop. So let me just sneak over here. I added my alpha naphthol and my 40% potassium hydroxide. Oh, good, you guys. And it's only been about 5 minutes. And it's like initially not very dramatic. But folks, can you see, and I'm being a bad example here. I should be gloved up. So again, folks, in 30 minutes, the color will probably develop much more dramatically. But here's my Enterobacter orogenes. Can you see a little bit of red developing? That's telling me acetoine is present. Now, why is the presence of acetoine significant in the BP test? What does that tell us? In which type of fermentation? The 2,3-butane-diol fermentation. So you guys, this is Enterobacter orogenes. It's VP positive, and that tells me Enterobacter orogenes carries out the 2,3-butane-diol fermentation, or butylene glycol fermentation. Okay. And folks, on the lab exam, it would be fair for me to ask you, which reagents do you add? So you want to know it's alpha naphthol and 40% potassium hydroxide. Okay. And folks, this would be our E. coli. Do you see any red? No. Okay. So you guys, let's fill in our table then. So then, folks, on the E. coli VP, did you see any red? No, not red. So is that positive or negative? That's negative. What does that tell you about your E. coli? Does not use butylene glycol fermentation, does not use 2,3-butane-diol fermentation. And folks, does this make sense? We had already determined which fermentation pathway E. coli used, the mixed acid fermentation pathway, right? And usually in nature, a microbe will have enzymes for one fermentation pathway or another. So usually in nature, like if your microbe is MR positive, you would predict it would be VP negative. There's always weird exceptions, but for us, that'll do. Okay, and folks, on your Enterobacter orogenes, VP, was it, what color was it? Red. And is that positive or negative? Positive. And so, folks, what's the interpretation? What does that tell us about Enterobacter orogenes? Yes, it uses a 2,3-butane-diol fermentation. Good. Or butylene glycol fermentation. Good job, you guys. Excellent. Folks, let me just ask you this. Do you think there are some microbes that carry out fermentation that would be both MR negative and VP negative? Yeah. So just think of, folks, remember the lactic acid bacteria? They carry out lactic acid fermentation, right? That really simple fermentation pathway. They would be both MR negative and VP negative because they're using another fermentation pathway. Good. Okay. And folks, on your Simmons citrate agar, what color was E. coli? Green. Okay, so green, and we could put not blue. We'll put not blue, and we'll put green. Good. Is that positive or negative for use of citrate as a sole source of carbon and energy? That's negative, yeah. And you guys, hopefully, what color was your Enterobacter on the Simmons citrate agar? Was it dark blue? Yeah, that's like my favorite test. I love that. They call that dark blue color, it's sometimes called Prussian blue. So this was blue. Is blue positive, folks? Uh-huh. And so what does the positive citrate test tell you about Enterobacter orogenes? Yeah, it can use citrate as a sole source of carbon and energy. Good job. Okay, now folks, remember how we introduced this saying the IMViC tests are awesome because it lets you, within 24 hours, distinguish between E. coli and Enterobacter orogenies. Okay, so you guys, if I asked you on the lab exam, what are the IMViC results for E. coli, we would go positive, positive, negative, negative. Positive indol, positive methyl red, negative VP, negative citrate. Does that make sense? So you guys, how would you score then your Enterobacter orogenies? Is it going to be the opposite? It's going to be the opposite. Negative, negative, positive, positive. So folks, remember that. Memorize that. Like maybe when you get your lab exam, just quickly write it at the top of your answer sheet, right? So you don't have to spend a lot of time or a lot of energy trying to remember it. So E. coli and Enterobacter orogenies, they have the opposite IMViC results. So you guys, try not to look at the board. So what are the IMViC results for E. coli? Positive, positive, negative, negative. What are the IMViC results for Enterobacter orogenies? Negative, negative, positive, positive. Yeah, good job, folks. Well done. Okay. And then, folks, just another benchtop test we ran on Monday was a Catalase test. So, folks, what was the reagent you used for the Catalase test? 3%. Okay, now be careful. See, and it's so easy to confuse you guys. I get confused. So, you guys, what was the reagent we used for the Catalase test? 3% hydrogen peroxide. Awesome, you guys. And it's so easy to get it mixed up with potassium hydroxide. But remember, you guys, we're using 3% hydrogen peroxide. Okay, so you guys, what would a positive Catalase test look like? Benchtop test, mix your microbe with a bubbles, good. So you guys, who was Catalase positive? Your Staphylococcus epidermidis or the Lactococcus lactis? Staphylococcus, good. So you guys, all members of the genus Staphylococcus are Catalase positive. Okay. And what about your Lactococcus lactis, you guys, when you mixed your Lactococcus with hydrogen peroxide, what did you see? No bubbles, right? So is that Catalase positive or negative? Good, okay. And folks, two things. You might ask, well, how does Lactococcus survive in an aerobic environment? Lactococcus, you guys, is related to the genus Streptococcus. And they do have a protective enzyme called peroxidase that breaks down hydrogen peroxide. It's just that it doesn't create molecular oxygen, so there's no bubbles produced. But it still has a protective enzyme. So these guys have a peroxidase. Where in contrast, all members of the genus Staphylococcus have true catalase, just like we do. We have catalase too. And folks, again, you're like, well, who cares? Well, often, folks, like if you're working in a diagnostic lab, there are many members of the genus. Well, no, I should back up here. There are pathogenic members of the genus Staphylococcus, and there's pathogenic members of the genus Streptococcus. And the challenge is, folks, both of these guys are gram-positive cocci. So if you did a gram stain, and you're reporting them as gram-positive cocci, it might be that you initially like to know, are these little guys potentially members of the genus Staphylococcus, like Staphylococcus aureus, very virulent, very invasive, often resistant to multiple antibiotics, or could it be a member of the genus Streptococcus, which in general aren't quite as tissue invasive, right? And in general, they tend to be sensitive to more antibiotics. So you guys, so if you had your microbes in pure culture on a plate, you could just run a catalase test, right? And if you're catalase positive, that's good evidence that you might be working with Staphylococcus. And if it's catalase negative, it indicates it might belong to the genus Streptococcus. Okay, so you guys, hang on to that for the lab exam, because there might be like a clinical case where you have these gram-positive cocci, trying to figure out, are they belong to the genus Staphylococcus or Streptococcus? Which quick test could you do to distinguish? Catalase, okay. And if bubbles on the catalase test, then it suggests it belongs to the genus Staphylococcus, like Staphylococcus aureus. No bubbles, it suggests, well, it might be Streptococcus. Good, good, you guys. Excellent. Okay, so folks, let me, apologies here. Let me stop this little movie. And then what we next want to discuss, you guys, and this is kind of complicated. We want to next discuss our TSI slants, okay? And there's a lot of information we're going to harvest from our TSI